Welcome to Sundar's lecture. This is lecture number 27, and in this lecture we are going to see some other flip-flops, maybe D flip-flop, JK flip-flop, T flip-flop, and their excitation tables and characteristics equation, which are going to help us in designing the synchronous sequential logic circuit or in analyzing the synchronous sequential logic circuit. Anyhow, we are in the beginning stage now, and what are all the topics we have seen in the previous class? See, we have started with the SR latches, and I have told you what is the difference between sequential circuit and the combinational logic circuit, and we have started with the SR latches, and then we have gone to see what is SR latches. We designed with the NAND gates, only NAND gates, and we have seen what is SR latches with enable input, and we have changed the enable input to clock pulse. In sense, we are saying it as a flip flops, right? And in clock pulse, we have seen there are two types of clock pulses, level triggering and edge triggering. And in level triggering, we have positive level triggering, negative level triggering. And in edge triggering, we have positive edge triggering and negative edge triggering, right? So we have seen these kind of things, and we have taken an example to understand what is the level triggered flip flop. And we have seen an example with the positive, sorry, not level triggering, edge triggering. Positive edge triggered flip flop, and we have seen how it works like here. And then now we are going to see what is D flip flop now. See, it is very simple. If you know what is SR flip flop, from the SR flip flop we can derive all other flip flops. The base idea is only the SR flip flop, and we are designing the other flip flops based on the SR flip flops. For example, in SR flip flops, you see, let us take this one now. The first condition, what is this one? S is equal to 0, R is equal to 0, then this is a no change condition, and we cannot give 1 1. S is equal to 1 and R is equal to 1 is a forbidden condition in SR flip flop, right? So now what we are going to do now, we are going to neglect those two steps, those two states, right? So for that, what we are going to do, we are just putting this is actually until this point, maybe if I draw it, it will be very easy to understand anyhow. See, this one is fully an SR flip flop, right? Fully. You can understand until this point. This is an SR flip flop, and for the clock pulse, we will put this AND gates, right? Put this AND gate, and if you give clock pulse, even we can add this one as an SR flip flop now. And what we are actually doing now, this is actually now S. This input is S. This input. And this point is R. That is what we have taken. But I have given here, anyhow, to give the clock pulse, we have added these two AND gates. That is what we have seen in the previous class, anyhow. So now what we are actually doing here, we are just putting an NOT gate for these two inputs now. What happens now? For example, if I give D is equal to 0, so I am making it to D now. So this 0 will go here. Let us assume that there is a constant clock pulse is available. So if it is 0, then S is equal to 0. This 0 will pass through, right? Because this is an AND gate. If this input is high, then this 0 will pass through this one. So S will become now 0. S will become now 0, right? And this 0 is getting 1 here, 1 here. So this one will also go inside this one because the clock pulse is high. So R is equal to 1. So what happens now? If I give D is equal to 0, D is equal to 0, in sense, in SR flip flop, I am giving S is equal to 0, comma R is equal to 1. What is this condition actually? What is this condition? This is a reset condition. Reset condition, right? We know this one. From SR flip flop itself, we know this one. So this is a reset condition, and what should be the output now? Whatever the input it may be in the previous state, the present state is going to become what? 0. Or the present state is anything, it may be the present state. The next state should be what? 0. Q output will default, by default it becomes 0, right? That is what we have given here. See here, maybe you take, if clock pulse is 0, then it is a previous state. Maybe S is equal to 0, R is equal to 0. No input has been given. So obviously what happens now, because if this there is no clock pulse, then both input will become now 0, and if both are 0 in SR flip flop, it will remains in a no change condition. Maybe I am not going to take this one for understanding. I have just written here. Anyhow, if I give 0, it becomes 0. And for example, we take another one now. If this one is maybe I will rough it out because it will be confusing. So if I give 1 here, if I give 1, what happens? This S will become now. So if D is equal to 1, I am giving D is equal to 1. So what happens now? S will get now 1, S is equal to 1, and this one will become 0 here, and that passed through this AND gate. So R will become now 0. And what is this condition in SR flip flop? It is a set condition, right? Set condition. And in set condition, what is the output? What should be the output? Output should be by default it is 1. Whatever the input it may be, whatever the previous state or present state it may be. Previous state means the next state will be 1. If present state is 0, the next state will be 1, right? So this is what happening here. So now in D flip flop, we have only 2 states because we have only one input, right? How many combinations? It will be 2 combinations. If D is equal to 0, then whatever the present state, the next state will going to become 0. Even if it is 1, it is going to become 0. And if I am giving D is equal to 1, by default the next state is going to become 1, even if it is a 0 in the previous state, right? So this is the next state condition, and whatever it may be, there are only 2 outputs, either it may be 0 or it may be 1, depends on the D input, that's all. So this is the explanation of a D flip flop. And now we are going for JK flip flop, and JK flip flop is also same as the SR flip flop, but only one condition we are going to neglect here. And what is that condition? Well, it's not neglecting, we are going to add that condition into flip flops. What is the condition we have left in the SR flip flop? It is the last condition 1 1, that is forbidden condition, because I have already told you there is a race between the 2 outputs. Any one gate, if it has less propagation delay, then that gate output is going to become 1, and the other one is also trying to become 1. So it is not a correct one because Q should not be equal to Q bar. That is our idea. So that is what we have seen. Anyhow, so now I am not going to explain you all these conditions because everything you know already. So if this is 0 0, if I give J is equal to 0, K is equal to 0. So if it is 0, one input of AND gate is 0, then S will get 0, R will also get 0. Simply, whatever the clock pulse it may be, I don't need to consider it to be. So S and R to be 0, so it is no change condition. And if I am giving 0 1, everything will be same as the SR flip flop. And now let us assume this Q is 0 and the Q bar, obviously it will be 1, right? You know that one. If this is 0, this will be 1. And I am going to explain you now, if J is equal to 1 and K is equal to 1, what happens? So this 0 will go here. So this will be now 0. This 1 will go here. This will be now 1. Let us assume the clock pulse is very high at all time. To understand things, I am just giving this one. So this one becomes now 1, right? Am I right or wrong? So this will be now. So by default, I am going to make this clock pulse to be 1. So that is what I have written here. So this will be also 1. So now you see all 3 inputs are 1. So yes, will get 1 here. And since this is 0, this input is 0, this output of AND gate becomes 0. So what is this one now? It is S is equal to 1, R is equal to 0. Then what is the condition? It is a set condition, right? So previous state it is 0 and this 0 is going to become now 1. If this is 1, obviously what happened to this one now? If S is equal to 1 0, then obviously this Q bar becomes 0. Try to understand, right? So this is the idea now. For example, you take a different one now. Let us assume that one also. So now this 0 has become 1. If I give J is equal to 1, K is equal to 1, the present state is 0, next state becomes 1. That is what we have seen now. And what we will do now, we will rough everything now. everything, since we are going to take another one now. Anyhow, the point is j is equal to 1 and then k is equal to also 1. This is not changing now, and this clock pulse is also 1. Let us assume the clock pulse is there for our understanding. Now I have assumed this to be 0 last time. Now this one I am assuming it to be 1. So obviously this has to become now 0. So what happens now? This one will go here now. This becomes 1 and this 0 is going here. So what happens here? So this output becomes 0. This output becomes 1. And what I am getting now? S is equal to 0, comma, R is equal to 1. And what is this condition in SR flip flop? It is a reset condition. Reset condition. So if reset condition is there, what should be the Q value? It becomes, obviously it becomes 0. So this one will go into 0. Then this automatically it should become 1, and we know that we don't need to bother about this one. So anyhow what is happening here, if the present state is 0, if I give 1 1, it is going to become 1. If the present state is 1, if I am giving j is equal to 1, k is equal to 1, this is going to become 0. Can you understand what is happening here? It is toggling, which means the output is going to change from its states to its opposite one. So that is what we have just written here. See this one now. This is a toggle state. Qn bar, which means if the previous state is 1, it is going to become 0. If the previous state is 0, it is going to become 1. So that is the idea behind the JK flip flop. Now we can use all 4 conditions. You can give 0 0, 0 1, 1 0, 1 1, whatever you want, you can give here. There is no restrictions, right? That is what JK flip flop tells us. And I can see here, and you can see I have just drawn the negative edge triggered JK flip flop here. Maybe this is preset condition and clear condition. Maybe preset means you can set the output to a certain value, and clear means if you press this one, the output becomes 0 by default. Maybe these 2 pins are for the IC design. Anyhow, this is JK flip flop with a negative edge trigger, and this is a JK flip flop with positive edge trigger. I have just shown you the whole diagram. We will not use this one again and again. No, we will generally put this one. Right? You have to understand that this is a JK flip flop. That's all. Right? So the next one, we will go to the T flip flop. And what is the T flip flop now? It is also very interesting to understand. Actually, this is a JK flip flop. This is a JK flip flop, right? Until this one, maybe if I put the diagram so that you can easily understand. This is a JK flip flop. Up to this one, it is a JK flip flop. Normally, this is one input. This is one input J, and this is the another input K. Here and here it is J and K. And what we are going to do, we are going to just short this J and K and take as an input T. What happens? If you give T is equal to 0, both will become 0, J and K, right? If T, maybe I will write it down. If T is equal to 0, then what happens? J will become now 0 as well as K will become 0. And what is this condition? If J is equal to 0, K is equal to 0, you know that this condition, which is nothing but no change condition, same as the previous state, right? And if I give T is equal to 1, what happens? T is equal to 1, J will get 1, K will get 1. So J is equal to 1, comma K is equal to 1. And what is this condition? J is equal to 1, K is equal to 1. It is a toggling condition, right? Toggle condition. So in JK flip flop, simply you have only two conditions. One is no change and one is the toggle condition. For example, you see here, if T is equal to 0, if the present state is 0, what should be the next state? It will be 0. See, since it is 0, no change condition, it will be there. And see here, if T is equal to 0, and you see here, T is equal to 0, so Q is 1. So again, it is going to become, it is a wrong one actually. Maybe I will write it down again. Maybe this truth table is a wrong one. And you see, just I have written here, if t is equal to 0, if qn is 0, then what should be the qn plus 1? It will be also 0 because no change condition. If t is equal to 0, if qn is 1, the next state will be also 1. And if t is equal to 1, if qn is equal to 0, then what should be the next state? It will be 1 because it will be inverting, right? Because toggling condition will occur. So if t is equal to 1, if this is 1, then this becomes 0. Simply, right? So this is the truth table of a T flip flop, right? So the next title, it is very important. Try to understand the characteristics equation as well as the excitation table. It is a very important topic because we are going to analyze the sequential logic circuit as well as we are going to design the sequential logic circuit. In both cases, we need to know the characteristics equation as well as the excitation table, and also we are going to design the counters, synchronous counters using different flip flops. So in those cases also, it is very important to understand the characteristics equation as well as the excitation table. So please be attentive in these stages. Don't lose your attention because if you don't know this one, then it will be nothing to understand counters, designing procedures, analysis procedure. Anyhow, because it is very easy also. Anyhow, see, this is the characteristic equation for SR flip flop now, and we know these conditions, right? Obviously, we know if S is equal to 0, R is equal to 0. If Qn is 0, Qn plus 1 will be also 0. If S is equal to 0, R is equal to 0, then it's a no change condition. We have already seen this one. This is no change condition, and this is a reset condition, and this is a set condition, and this is a forbidden condition. Forbidden condition, right? You cannot give this one. So you can put as X here. You don't know, output may be anything. It is not given. You cannot give this one. So we never give this input to SR flip flop, right? Now what is this one now? You take these three as an input now, because we know those kind of things. I know what is S value, I know what is R value, and I know what is the present state value, and I need to know what is the next state. I need to find what should be the next state, right? So what I am doing now, I am taking these three as input now, right? These three as input, and this is the output. Draw the camera, simplify it. Very simple, right? So maybe this is the simplified truth table. Simplified, you know this one. I have already told you. This is simplified truth table. And see this one, I am taking this to be SR and this to be QN. So you know, right, for drawing the corner from 0, 0, 0, 1, 1, 1, 1, 0. So this will be S bar, R bar, and this is S bar, R, this is SR, this is SR bar, and this is Qn bar, this is Qn, right? We know these kind of things already. And what you can do now, you put this one 0, 0, 0, it is 0, right? So this is a min term. If you write it in min term, this is 0, 1, 2, 3, because the you see this one 0, 0, 0, 0, 1, everything we know already, right? So this is 5, this is 6, this is 7, and if you put this one, this is 0, 1, 2, 3, and 4, 5, this is 6, and this is 7, and you just substitute all these values now here itself. So these are all 0. So is there any quad possibility? Yes. If you put this X, you consider this X to be one thing. So this is one quad, this is one quad, and these two can be made to be pair. So for this pair, you will get what? You will get this equation, right? So the common term is in both terms, it is R bar and it is Qn. So I have written this one. And for this quad, what is the common term in these two? Simply it is S, right? Both are common and there is no common term here. So simply, finally what you can write? So Qn plus 1 will be is equal to S plus R bar Qn. This is the characteristics equation of a SR flip flop. So SR flip flop will behave like this. If you want to know what is the next state, and you know what is the present state and value of S and R, you can substitute here and you can easily understand what should be the next state. So this is the characteristic equation of a SR flip flop, right? Can you understand? This is the idea. And we will go to the next one now. Maybe I have became very long. No, right? DT is here. Okay, anyway. So this is JK flip flop now. So you know this is the input now. So these two stages. So right, we know this one, right? So what is this one? So same conditions, right? So it is 0, 0, 1, 1. So no change condition. This is no change condition. And these two, if j is equal to 0, k is equal to 1, it is a reset condition. And these two, whatever it may be, the previous state, the next state will become now 1. So it is a set condition. And this one, if this is 0, it is going to become 1. If this is 1, which means the previous state is 1, the present state is going to become 0. So this condition is a toggle condition. That is the only difference between the SR flip flop and then JK flip flop, right? So that is what we have done here. So you just put these values, these numbers, digits into the Karnaugh map. So we will get like this one now. So it is J bar K bar, it is J bar K, it is JK, it is JK bar, and this is QN bar, and then this is QN. So if you put this one, write the min terms, you know all these, those kind of things. So there are only two pairs here. So what is this pair? This pair, the common term, it is QN bar will come. So JQN bar. So this is the first one. That means this pair, first pair, and the output of the first pair is written here. So the next one, these two pairs, the common term is QN here. And what is the common term here? It is K bar. So K bar, this is the second pair, and this is the second one, right? So what is the equation for JK flip flop? To find the next state, it is J multiplication of, that means and of QN bar plus K bar and of QN. R. In center it is R. So this is an important equation. So we always go for JK flip flop. So you try to understand and remember this one. So this is a simplified truth table, all those kind of things we know already. We will go to the next one now. D flip flop, it is very simple. Why? Because only two inputs, right? So if only two inputs, then there will be four different combinations, right? 0, 0, 0, 1, 1, 0, 1, 1. And what is these two? It is sorry, no change, right? It is a reset condition. Only two conditions will be there in D flip flop. One is reset condition and the another one is the set condition. We have seen this one, right? So if you put this one here, put the truth table into the Karnaugh map, and we will get this is D bar D, QN bar QN. So this is the idea. We got this to be 1. So this is the pair now. So this pair, the output equation will be Qn plus 1 will be is equal to, straight away it is D. So the idea is very simple here. What is the idea? The characteristic equation of a D flip flop will be D. Whatever the input you are giving, that will be reflected in the output simply. Right? It is 0, 0, 0, 0, 1, 1, 1, 1. So whatever the input you are giving, that will be the next state. That is the idea, whole idea, right? And we will go for the T flip flop now. So in T flip flop, the idea will be this condition. If it is 0, then these two conditions are no change condition, right? This is only two states. The D flip flop is set and reset, and the T flip flop will be no change, and the final stage it is a toggle condition, right? You see here 0 becomes 1, 1 becomes 0, so it is a toggle condition. So only two states again. So so it will be very simple to put it in the Karnaugh map. Put the value, so it will be T bar and it will be T. It is QN bar and it is QN. And you don't need to see this one because you don't have any what to say, pair or quad. Anything is not possible here. So finally you can write this one. It is like an XOR gate. Two inputs, XOR two inputs. So what will be the XOR gate? AB bar plus AB bar. Sorry, AB bar plus A bar B. That is what they have written here simply, right? So this is the characteristic equation of a T flip flop, right? So what we have done in this class, so we have seen different types of flip flops. We have seen SR flip flop in the previous class, And in today's class, we have seen what is D flip flop and why we are going for D flip flops, right? So to neglect the first step and the final step in a SR flip flop, we can go for only set and then reset condition. That is D flip flop. And we are used the unwanted state in the SR flip flop, that means forbidden condition. We have included that condition also in the JK flip flop. For that, we have designed a 3 input AND gate, right? So that is what we have seen here, and we have gone to see T flip flop. T flip flop is going to use only 2 states, that is the no change state and the toggle state. The straight opposite to the D flip flop, right? So all the 4 states are used in JK flip flop. 3 states are used in the SR flip flop, and the other 2 states, vice versa states, will be used in D and T flip flops, right? And we have seen the characteristic equation for all the flip flops. This is for SR flip flop, this is for JK flip flop, this is for D flip flop, and this is for T flip flop. Thank you. We will see in the next class, and we will see what is the excitation table in the next class. Thank you.